Hello, good evening, guys. Happy Tuesday. Right, as you can see, I look a bit more clear today. Oh, I look this clear last week also, huh? Because I changed my laptop. Okay, hello everyone. Hi Felice. Hi Terence. Hi Jingen. Hi Chloe. Hi Lemin. Hi Jaden. Hi Weijun. Hi Jenny. Hi Wing. So hello guys. Nice background. Thank you. Okay, it's a meme. Can you recognize the meme? Okay, so guys, today we are continuing with our static. I think we have done static, right? We have done static, right? So last week, the one I mentioned, which is static. All right. So proton cannot move, only electrons can move. So when the electrons they jump, you will see a Z. That is what we call your electrostatic 静电. Okay, your electrostatic. And I think I told you this, light charges repel and different charges attract. Okay, so this one you know, and I think I mentioned this in the daily life thing already. So you have thunder, you have lightning rod, you have the oil tanker one, you have the Van de Graaff generator, and you have like the aeroplane discharge wakes in the sensor. Okay, so guys, today we are going into electricity. We are going into electricity. So please get yourself ready. This would be a big problem for you, especially if you're a girl. Okay, I'm not trying to be sexist, guys, because usually girls doesn't mix very well with electricity. Which page is this? 30, page 30. Shall we go to page 30? Right, so page 30, page 30, you must leave, don't want electricity. Okay, guys, I don't know about you, actually, electricity is quite simple. You think it's very difficult because you haven't met the right teacher. Okay, so guys, I want you to imagine, okay, what's the difference between static and electricity? Guys, let me explain. What's the difference between static and electricity? The difference is static is a jump, right? Static is a jump. Like I said last week, when you walk in a shopping mall, you touch your friend, you feel that shock. That is a jump, right? But electricity is a flow. Electricity is a flow of electron. Last week, thunder, lightning is jump. You see, from the cloud, they jump to the ground, no more. That's one, right? It's like explosion. One bomb is no more. But electricity is like a constant flow. It's like burning. You see, burning and explosion, they are both combustion. But burning is a slow and steady and continuous thing. Explosion is like a pop, no more. So the difference is this, static and electricity, okay, which is 电流. Electricity is your 电流. All right, so let's talk about electricity. Let's talk about electricity. Electricity is the flow of electric charges. You see, flow, 流动，所以叫电流。Static is a jump. Okay, it is produced by the flow of electron. Electron, they flow, you have electricity. You see, electron, electric, electron, electric. So when electron flow, you get electricity, right? So they will go from positive terminal to negative terminal. I'm sure when you see your battery, you will know lah. The nipple side, the side that looks like a nipple, the nipple side is positive. The non-nipple side is negative. This one you know lah. Okay, the nipple and the non-nipple side. Okay, so this is a flow. Okay, this is a flow. And then, okay, okay, I want to think of it this way, guys. Imagine electricity is like a river. Imagine electricity as a river. And instead of water, okay, you see, river has water flowing, right? River has water flowing, right? 你的河是水在流. River is water flowing. Electricity is electron flowing, right? Like a sea of electron flowing. river of electron flowing. That's the difference. All right, so that's the difference. Anyway, when we talk about electricity, we have to talk about three things. When we talk about electricity, we have to talk about three things. We have to talk about the current, okay, the current, the voltage, and the resistance. All right, the resistance. Guys, just before I proceed, anyone learn this already? I think Felice, you learned it, right? Because you were asking about this a few weeks ago. Learning, yes. Oh, wait, you learned already, huh? You guys learned already? Like just learn or long ago? Or just learn? Then can you understand? Can you understand what you learned in school? Oh, last week, huh? Oh, but no. No, Jenny, no. Can't understand. But Wayne, you understand? Wayne, you understand? You understand electricity? Yes, reason being, teacher is not the one teaching. Huh? Oh, that means presentation. Yeah, why so lame one? Seriously? Well, then you guys should get the salary though. You guys should get the salary because you're teaching about yourself. Yeah, what kind of shit is this? Okay. Anyway, okay. Guys, let me you will sure understand, right? See, this is the power of teacher ID. I will make you understand. Okay, guys. So current, voltage, and resistance. Current, voltage, and resistance. Okay, let me just put it in Mandarin. Current is your 电流. Okay, just like your electricity. Current is 电流. Voltage is your 电压. Okay, and then resistance is your 阻力. You know resistance? I'm fighting you. Resistance. Okay, guys, very easy. Imagine your river. Imagine this is a river. The width of the river, it's called current. 河流的宽度, the width of the river is called current. All right, and then voltage is the speed of the river. The speed of the river, 河流的速度. This current is how wide the river is. 河流有几宽. This voltage is how fast the river is. 河流有几快. Can you see the difference? Okay, put it this way, right? If there's a very thin river, but they go very fast, this is high voltage, low current. Oh, by the way, this is the symbol. Current is I, voltage is V, resistance is R. Why is current I? Don't ask me, but very easy to understand. Can you see when I measure my current, I do it like this. The width of the river is like this. So you see I lo. So current is I. So you see, if this is a very fast and narrow river, high voltage, low current. Understand? Understand? If this is a very wide river, it is very slow. Wide river and very slow. This is low voltage and high current. Can you understand? Can you understand? 河流很快，可是很窄。河流很慢，可是很宽。So you see, fast and narrow river, slow and wide river. So that's the current and voltage. Okay, what about resistance? Resistance is the same thing. Resistance is the force fighting you. Think of them as rocks. You see, in every river, you have rocks, right? You have rocks blocking your electricity from going. I don't care how smooth your river is, there will be rocks. There will be rocks. 一定有石头在你的河里面的. So the rocks are going to slow your river down. That's your resistance. Resistance is anything that is opposing your electricity. It's fighting your electricity. It's slowing you down. All right. So definition. Current is the rate of flow of negative charge. Rate of flow of negative charge. Right. That means how far, how wide are they flowing? Voltage is the electrical energy needed to move electrical charge from one point to another. Okay, you know what, guys? Don't care about this. Don't care about this. This is not to do with you. Okay. Resistance, they oppose the flow of electric current. Resistance is fighting you. You see? Very easy, right? Very easy, right? Current is the width, voltage is the speed. You understand this first? Because I am sure you guys learned this in school, right? Series and parallel. 串联并联电路. This is the killer one, right? Because you have 3 formulas to remember. Oh shit, there's 1 column missing. Okay, there's three formulas to remember, and this will make things even worse, right? Jenny, I think the one you don't understand is this, right? Is it? Because usually series and parallel is the hard one. Okay, I'll talk about that later. Right, so let's talk about current and voltage. Okay, how do we measure current? We measure using ammeter because the unit is ampere. Ampere, ammeter. Ampere, ammeter. Volt, voltmeter. Voltage, voltmeter. Resistance, we cannot calculate. Resistance, we calculate by using current and voltage. We can use this tool to calculate the resistance. Right, really easy. And then the symbol for current is A, because ampere ma. For voltage is V. Voltage is very easy. You see V. Voltage, volt, everything is volt. This one easy. And then resistance is ohm. Resistance is ohm. Why is it ohm? What is this symbol, guys? This is omega. It's a Greek symbol, 希腊文字. Okay, omega. Don't ask me why they use omega, because the guy who found this thing is called Ohm's law. It's his law. So we use omega. All right. So, okay, this one you don't care. You don't care. You just have to know this. Current is the width. Voltage is the speed. That's all you need to know for now. All right. And how are these 3 related together? How are these 3 related? This was what mentioned by Ohm's law, right? Ohm's law. Ohm said, okay, Ohm said R equals to V divided by I. R equals to V divided by I. Resistance equal to voltage divided by current. R equals to V over I. This is what Ohm said. That means voltage divided by current, okay? Speed divided by width, it's your resistance. Okay? The current that flows through a conductor is directly proportional to the voltage across the end of the conductor. You know what? We don't care. We just have to know this. Okay. I don't memorize this. I just memorize V equals to IR, which is the same lah. You move the I up here, it becomes IR long, because I think VIR is easier to memorize. Okay, that's what I think lah. Okay, V equals to IR. That's what I use. Okay, you want to use R equals to V over I? It's okay. It's up to you. All right, guys. Do you know how to use this formula? Do you know how to use this formula? I think you do, right? I think you do, right? Yes, okay, so then I'm just going to speed this through, So when a voltage of 3 is applied across a conductor, the current flow is 0.5. What is the resistance? Guys, just follow your formula. This is your voltage, V. I just like to label my numbers so that I don't get confused. Current flow is 0.5A. This is I, because current is I, man. Okay, current is I. So we have V, we have I. So what is the resistance? So R equals to V over I. V is 3, I is 0.5. 3 divided by 0.5, we get 6 ohm. Easy? Easy? Lavin, are you okay with this, Lavin? I know you hate electricity, but at least you can understand this, right? Right? I guess I think you do, lor. How can you not understand this? Right? This is like basic level maths, what? You just put two number to find one unknown. Okay, basic you can handle. Good. Guys, I'll make things as basic as possible. You will definitely understand. Right, let's go to number 2. The figure shows a simple circuit. Calculate the resistance of the light bulb if the voltmeter reading is 12 and the ammeter reading is 3. So my ammeter reading, basically this is the I, the current. 12. This is the V. Okay, they want you to calculate the resistance, which is the R. So R equals to V over I. R equals to V over I. V is 12. I is 3. So 4 ohm. Okay, okay, At this point, you're like, sir, why are we learning this? Why is it so simple? Yeah, you bet, because it is that simple. So number 3, the figure shows an electric circuit. What will be the reading of the ammeter when the switch is closed? Okay, closed means they connect. Closed means connect. So 2 ohm, this is your resistance R. 10, this is your volt. R equals to V over I. So they want you to calculate the reading of the ammeter, which is the I. So R is 2, V is 10 divided by I. So I equals to 10 over 2, which is 5 ampere. Basic maths, you understand, huh? I switch place between I and 2. You know how this works? How this becomes this? You guys know how this becomes this? You understand, huh? You understand, huh? This is maths, huh? This is nothing to do with science already. Your linear equation. Moving. So next, number 4. What is the reading of the ammeter shown in the figure? What is the ammeter reading here? What is the I here? This is the V. This is the R. So R equals to V over I. Right? So your R is 4, V is 10, and your I. So I equals to 10 over 4. You will get 2.58. Okay? 2.58. Okay, cool. Cool. Of course, this is the basic lah, right? So number 5, a light bulb is connected to in series to a 12-volt battery. Okay, we don't care about series first. 12-volt V. Resistance of the light bulb is 6 resistance. Calculate the current. Guys, I know you might say, sir, very excessive, no need to label lah. Just make it a habit lah, right? Because next time when you go at maths, when you go physics, like when you learn about speed, you have like 5 numbers there. So you better label. Just don't be lazy. Make it a habit because you won't get confused this way. So R equals to V over I. 6 equals to 12 over I. I equals to 12 over 6. You will get 2 ampere. Okay, 2 ampere. And next, what is the reading of the ammeter shown? So this is your V, this is your R. R equals to V over I. V is 6, I is 12. Hey, sorry, what am I doing? 12, this is I. So I equals to 6 over 12. I will get 0.58. Okay, 0.58. Okay, so next, what is the reading of the voltmeter shown in the figure? So this is your I current, this is your R resistance, R equals to V over I, 3 equals to V over 1.5, V equals to 4.5, because put up is times V. Okay, I'm just speeding this through. You understand? Basic maths. So number 8, the resistance of a resistor in an electric circuit is 4. That's the R. What is the ammeter reading? This is what they want. If the potential difference is voltage, it's just a very fancy way to say voltage, is 5V. So R equals to V over I. 4 equals to 5 over I equals to 5 over 4. So it's 1.25. A. Right, so do you have any question? It's just the same answer, the same working, the same formula over and over and over and over. Oh. Right? So you understand, huh? Okay, let's go to the killer part. Right. I am sure this is where, okay, when you're learning this, you're like, okay, not too bad, not too bad. And then, oh my God, what the hell is this? Right? Suddenly the roller coaster drops and you are like, what the hell is this? Okay, so guys, let me explain. Okay, what is a series circuit? This is called 串联电路. That means you connect everything in one straight line. Okay, everything in one straight line. And then parallel circuit, this is 并联电路. You connect everything parallel. Okay, you connect everything parallel. Okay, what does it mean? What does it mean? Right, I want you to remind you, electric circuit is a river. Right? Again, I want to remind you, electric circuit is a river. Okay, so guys, let me ask you, this is a series circuit, right? Everything is in one line, right? How many river is this? How many river is this? Series circuit? Yes, this is one river. This is one continuous river. Okay, put it in your head first. One continuous river. What about parallel circuit? Let's say this. Let's say this. This is two rivers. You see, I have a main river. I have a main river, and then the main river just decide to split into two. And then the two river later they join back. They join back. Okay, make sense? Make sense? One river, two river. That means this river for series, the river they look like this. Okay, the river they look like this. And for this, the river they look like this. Okay, can you see the difference? Can you see the difference? Hello, Jingyan. I didn't notice you disconnected. Right, so you see, this is one river. This is one main river split into two. It's okay, it's okay. Right, so let me talk about the current, the voltage, and please add one more resistance here. I'm sorry. I don't know why the column gone. I don't know why the column gone. Right, so guys, let's talk about the current first. Okay, just now I said current is what of the river? What is current? What is current? Guys, what is current? Yes, but what's the river? The width of the river, right? 河流的宽度. Current is the width of the river, right? Okay, guys, let me ask you, if this is one straight river, will the width change? If it's one straight river down, will the width change? 宽度会改变吗? No. That's why you see, I equals to I1 equals to I2. If you want, equals to I3 equals to I4. That means the width of the river is the same everywhere. Voltage is the speed, remember? Please? Voltage is the speed. I'll talk about that later, right? So we are talking about the width first. You see, width of the river stays the same. If the width here is 5, the width here will be 5, 5, 5, 5. The whole river will stay the same width. Make sense? Make sense? So I don't get y'all say why, sir, this is so difficult. It's all common sense. Okay, next, let's look at the two river. Okay, the two river. You see, one main river split into two river. Is the width the same now? Can I say 5, 5, 5? Can I say this width here is 5? I split into 5 and 5. Can I say that? Is this true? No, right? It doesn't, isn't it? Because you see, when this river splits into 2, they got smaller. When they join back, they become bigger again. That means if this is a river of 5, this will become 2.5, let's say lah. This will become 2.5. And when 2.5 and 2.5, they join back, they become 5. Again. Huh? Easy, huh? Easy, huh? So you see, this is why I, which is the main width, the main river width, is equal to the first river width plus the second river width. That's why it's plus. That's why it's plus. That's why it's equal here, because same width. It's plus here because it's like width, this 2 width add together, right? If this is 5 here, this is 2.5 and 2.5. This is 5 here again. 5, 2.5, 2.5, 5. Okay, guys, am I making sense here? Am I making sense here? I am making a lot of sense, isn't it? Because this is completely common sense. Right, so let's talk about voltage, shall we? Voltage is the speed. Okay, voltage is the speed of the river. Okay, so I have a question here. You see, I have 3 resistance here. I have 3 stones I need to pass through. I have 3 stones I need to pass through. This is a river, right? This is a river. You see, if my river starts with a speed of 4.5, if my river starts with the I1 and I2 is different. What do you mean? It could be different, it could be same. It could be different, it could be same. But I1 and I2, when you add together, it must equal to the main. Can? So how you know? They will give one. In exam, they will give one. Okay, if let's say, just now I said 2.5 is 5, right? It could be this way as well. It could be 3.5, 1.5. Don't worry, they will give. Don't worry, they'll give. You just have to know for now. When you add these 2 width together, you get the main width. That's all you need to know for now. Whether they are same or different, we will handle that later. Can? Okay, so let's talk about the speed. Let's talk about the speed. You see, my river now needs to pass through 3 rocks because rock is a resistance, right? Rock is a resistance. 石头是那个阻力. It will slow your water down. It will slow your river down. So what is happening now? What is happening now? Guys, hang on. Yes, Yinghui, hello, good evening. Oh, you're late. I'm halfway through electricity already. Oh my God, such an important lesson, you're late. Okay, so let's start with here. Okay, this is a river of speed 4.5. This river, Yinghui, come get your video from me. Come get video from me because the front part you kind of missed it already. It's a lot of things. Okay, so this is 4.5, right? This is 4.5. Okay, see, my river speed is now 4.5. I'm traveling at a speed of 4.5. Again, yeah, WhatsApp me. Do you have my WhatsApp? Okay, this is the speed of the river going down at 4.5. When I pass through the first bulk, the first rock, I gave it 1.5. I slow down. I already slow down because I have to pass through a rock, right? Now, from 4.5, my speed reduced to 3. Okay, reduced to 3. And then passing the second rock, 1.5 again, I slow down some more 1.5. So now it's 1.5 left. Okay, this 4.5 already give this 1.5, I have 3 left. 3 give another 1.5, I have another 1.5 left. And then at last, 1.5 give this 1.5, I have 0 left. When my river has no more speed, it's very slow, it's time to go back and to recharge and to flow again. Right? So the total river speed in a series circuit, this is one river, right? The total river speed is all the speed adding together. You can think of it like energy. I have 4.5 energy. I give 1.5 to the first rock, 1.5 to the second rock, 1.5 to the third rock. So this one will just slow. right? That's why you came to this formula. V, total speed, is equal to V1, speed river 1, river speed 1, plus V2, river speed 2, plus V3, river speed 3. Okay, things like that. So V1 plus V2 plus V3. You have your total V. So you see this is okay. Let me finish this. Let me finish this. Okay, so let's talk about parallel. Let's talk about parallel. Okay, now parallel, right? Now parallel. Okay, let me draw like that again. Okay, this is parallel. Okay, this is parallel. Okay, your parallel river, if you start with a speed of 4.5, let's say 4.5. If I split into smaller river, when I split into smaller river, the river got smaller, right? The river got smaller, but the speed never changed. But the speed never changed. Only the width is becoming smaller, but the speed is not changing. This one, the speed is slowing down, down, down. But this one is same throughout. That means in a parallel circuit, I don't care where you are. I don't care where you are. I don't care whether you are here. This is 4.5. Here will be 4.52, 4.5, 4.5. It will be 4.5 everywhere. It will be 4.5 everywhere. It's equally everywhere. So guys, can you see something like this? Can you see something? Series circuit, width is the same. Width is the same. Speed is adding. Total speed is by all the speed adding together. On the opposite, parallel circuit is your width adding all together. And then your speed is the same everywhere. So can you see it's like reverse? This is equal. This is sum. This is sum. This is equal. It's like opposite of each other. Can you understand? Guys, can you understand? Can you understand? Really, really easy. If you cannot understand the speed part here, which many students, they still don't, you can ignore this. You just have to figure out this two and you reverse it. That's how you get it. Okay, you understand this two and you reverse it. That's how you get your voltage, your speed of the river. Right? Easy, right? I don't know about you, but for me, this is okay, not that difficult. Right? So this is your series and parallel circuit, your current and voltage, width and speed. Okay, last one. Let's talk about resistance. Okay, resistance is very easy. Your brain loading. Okay, now it might not make sense to you. Later when I do exercise, it will. Okay, resistance in your series is the same as this. It's by adding everything together. Right? You see, this makes a lot of sense. The total resistance of the river is by adding all the resistance together. Again, the total resistance of the river is by adding all the resistance of the river. Okay, the rocks in the river is by adding all the small rocks together. Can? And then since parallel is reverse, right? Since parallel is a reverse, then I will write the same thing. I'll write the same thing and I will reverse it. 1 divided by R instead of R. Because 1 divide is reverse, right? Because you see, R is like R over 1. So the reverse of R over 1 is 1 over R. They are the opposite of each other. They are the opposite of each other. Since they are already opposite here, so this one also opposite. Can? Understand? I mean, I haven't applied in question yet. Later it will make sense. All right. So again, let me repeat. With same throughout, adding everything together, speed reverse, resistance, adding everything together, reverse. Levin, are you okay? Jenny, are you okay? Are you okay? You understand this for now? Later exercise, I will apply it and then it will make sense. Yes, yes, very easy. Okay, guys, what is the advantage and disadvantage of both? Right, you see, advantage of a series. Okay, advantage of a series means you can control everything by one switch. You see, one switch, I can switch on everything. One switch, I can switch off everything. Right, which is the good point. But the disadvantage is when one breaks, when the river breaks here, everything cannot flow. When the river breaks here, everything cannot flow. So everything will switch off. That's why series is a very stupid design. Nobody uses series. Nobody uses series because it's very hard to use. One break, everything breaks. And now, if let's say this bulb breaks and everything doesn't light up, you don't know which one broke. You will never know which one broke. That is why we don't use series, but we use parallel. You see, parallel is good. Parallel, it allows other components to continue working when one component is switched on or switch off or burn out. That means if this thing breaks, I still have a river going through here. This still lights up. Okay, still lights up, so it doesn't affect anything. The increase in the number of electrical appliances does not affect the function of other appliances in the same circuit. Guys, if I add more light bulb here, the light bulb is going to get dimmer and dimmer and dimmer because I need to share the speed. You see, if this is only one light bulb, I am giving all 4.5 to that one light bulb. It will be very bright. But now if I have 3, I need to split this to 3. I need to split this to 3. Everyone gets equal share. So the more I add, the more they share, the dimmer the light bulb becomes. But in parallel circuit, I can just keep adding and keep adding and keep adding because they are separate circuit. The brightness will not affect. The brightness will not affect. But that also means your battery will finish faster. This one will use more electricity. Because I need, okay, imagine you are the dad. Imagine you're the dad. You give 4.5 to your children. The more children you have, you don't care. You still give them 4.5 ringgit. They have to split. So if you have one child, that child will get all 4.5. If you have 3 children, each will get 1.5. If you have 9 children, each of them get 0.5. So dimmer and dimmer and dimmer. But this dad is the PT one. He will give this child 4.5, this child 4.5, another 4.5, 4.5, 4.5. So everyone takes 4.5 from the dad, so the dad will die faster. Okay, but the advantage is when one breaks, the other still works. So not gonna affect anything. Okay, understand? Kind of easy, isn't it? Not to say easy, it's tricky, yes, I agree, but it's not difficult. Okay, so you know what, guys? Let's go and do some exercise, shall we? Let's go and do some exercise. Oh, sorry, why am I here? This is like energy heat already. Okay, let's go to exercise. Let's go to number 5. The previous one, the static one, if I have time, maybe I'll come back. Okay, let's go to number 5. Number 5. What is electricity? What is electricity? It's a flow of electrons in a circuit. Okay, in a circuit, they flow. Electron flow. Okay, so next, name instrument P and its function. You see, P, there's an A here. So P is an ammeter. We're on page 37, by the way. Ammeter function is to measure current. Because M means ampere. Ampere is the current. Okay, ampere is the current. Okay, next. Name instrument Q and its function. Q is the voltmeter. Okay, the voltmeter. Function is to measure voltage. Okay, is to measure voltage. Right? Easy, huh? So state the unit for current. Current, we use ampere, which has the symbol A. Voltage, we use volt, V. You see, volt is everything same one. Resistance is ohm, which is omega. Okay, E we skip, not really important. This is just the intro, guys. This is just the intro. We haven't gone into calculation yet. Okay, state Ohm's law. Ohm's law is resistance. Okay, resistance is directly proportional to ratio of voltage over current. Oh my God, sir, what is this? Should I memorize this? No. Right? If you want, you can, but there's no need to. Direction of flow of current is from positive to negative. As you already know, from the nipple of the battery go to the back of the battery. Okay, so H, draw and label a simple circuit which has dry cell, wire, switch, bulb. Okay, and then how you connect amp and voltmeter. So we have dry cell, wire, switch, light bulb. Okay, ammeter is here, voltmeter is here. Voltmeter, you should collect. You should always connect voltmeter in parallel. You should always connect ammeter in series. Okay, why? Because you see, to measure the speed, guys, to measure the speed of the river, I need to measure 2 points. I need to measure the difference in speed here. To measure the width, I just put this thing straight in the middle of the river. You see, to measure the width of the river, to measure the width of any river, you have to put the ruler in the middle of the river. Make sense? You put ruler in the middle to measure the width of the river. Oh, make sense? Oh, you see, that's why I always use river to explain, because now you understand. Right? If not, last time it's very hard for you to visualize. Oh my God, so what are all these? Right? So now it makes a lot of sense. So what would happen to the following when the number of cells are increased in the circuit? You have drawn in H. Right? Cell means battery. If I add more battery, what's going to happen? You have higher V now, more money, more speed. So there's more money to the light bulb. The bulb will have higher voltage. So that means they are brighter. So the brightness of the bulb will increase. Okay, it's brighter. Reading of the ammeter. Guys, what about the ammeter? What about the ammeter? Everything we use formula, right? R equals to V over I. Okay, let me ask you. Guys, let me ask you. Is the R changing? Is the R changing? Am I adding more bulbs here? Am I adding more bulbs here? I'm just adding battery. Am I adding more bulbs here? Am I putting like 2, 3, 4 light bulbs here? No, right? So the resistance doesn't change. Resistance doesn't change. But my voltage increase. My V increase. So what happens to the I? When my V increase, what happens to my I? Increase or decrease? Increase or decrease? In physics, you deal with a lot of this thing. Deal with a lot of explaining using formula. When my V increase, what happens to my I? Okay, let me put it this way. 4 divided by 4 equals to 1. So 5 divided by what equals to 1? When my V increase, my I needs to increase as well. Am I making sense? Am I making sense? Felice, am I making sense? 441, 551. When my up increase, down also increase. Okay, so reading of the ammeter will increase. Okay, what about the reading of the voltmeter? Of course, increase also, because you're adding more voltage already. So there's more V. Of course, it increases. Right? Right? But okay, here's the thing, guys. Here's the thing. When you use any appliance, your PC, your phone, your TV, your rice cooker, your fridge, your aircon, everything we need to follow the voltage. Okay, Malaysia voltage is 240. That means from the wall, what TNB gives you, you know, you pay TNB bill every month, right? What TNB gives you is 240. You always follow 240. Malaysia, we always follow 240. Right? Because anything over, right? See, because I have students asking me, sir, since I increase more battery, my light bulb will increase brighter, right? Then I just put 20 batteries lah. Yeah, it works, but okay, if let's say a bulb can maximum take 6 volt, you put 10 batteries and make it 15 volt, what's going to happen to the battery? Sorry, what's going to happen to the light bulb? The bulb can only, the bulb is using 6 volt, you are giving it 15. Is it going to be brighter? Is it going to be brighter? Yeah, it's going to be brighter, but it will burst soon. Too much voltage means the bulb will just overflow. The electricity is overflown, then the thing will break. Right? That's why if you are from the US, if you go to the US they use 120 volt. So if you buy something from the US and you use it in Malaysia, the thing is going to break. Right? The thing is going to break. Let's say if you buy a rice cooker from the US, they only use 120 volt. You plug it to Malaysia plug, our Malaysia plug will give 240, your rice cooker will just straight away burn, straight away break, because there's too much voltage. Right? If it makes any sense. So number 6, the current flowing in the nichrome wire is this thing here. Wait, where is it? There, this thing. The nichrome wire is here. It's measured with when different voltage are used. The following shows the installed circuit and tabulated experimental result. So you see, this is the V, this is the I. So according to R over V divided by 1. So 1 divided by what? 0.5, 2. 2 divided by 1, 2. 3 divided by 1.5, 2. 4 divided by 2, 2. What am I trying to say here? Resistance will not change. You see, I'm still using the same wire. I am still using the same wire. I'm still using maybe the same light bulb. So this thing will not change. Will not change. Okay? Will not change. Resistance will not change for fun. So how to increase the voltage in the circuit? How do you increase from 1 to 2 to 3 to 4? You add more batteries. So yes, you add cell, correct? Add the number of dry cells. Okay, you add more cells. So see, how does increase of voltage affect current flow? When I increase voltage, what happens to the current? I go from 1 to 2 to 3 to 4, the current also goes up. Increase. What about the resistance? What about the resistance? The resistance has no change, right? I don't care how fast my river goes. I don't care how wide my river goes. The number of stones is the same. I have the same stones in the river. I have the same resistance in the river. Common sense, Common sense, Okay, I hope this is common sense. So D, based on the calculated resistance value, write the relationship between voltage and current. So as voltage increase, current increase. Okay, I'm just lazy here. Okay, in exam, please write the full answer. When voltage increase, current increase. Okay, common sense. So calculate the current value using the formula in D if the voltage is 20. If I put this to 20 volt, what's going to happen? I have 2 ohm here. The resistance doesn't change. So my V is 20. Resistance is 2. R equals to V over I. R is 2. V is 20. I we don't know. So I is 10 ampere. Right? So it should be 10 here. Make sense? Z, V equals to I. We are still not using it. We are still not doing the parallel and series yet. Just to make you understand here first. So can you use the formula in D to make the same calculation if nichrome wire is replaced by a constantan wire? If I change the material of the wire, can I still use the same formula? Is the resistance still the same? Nichrome wire is 2 ohm. Will other wire be 2 ohm? No, right? No, because it will have different resistance. All right, it will have different resistance. That's why it's not going to be the same. You cannot use the same formula. Okay, huh? Can, huh? Okay. Okay, this one I just joined for fun lah. Just let you know lah. Dry cell, it's like this. Switch. Light bulb. I just like to draw it this way because it's fast. Ammeter, voltmeter, fuse, resistor. What is a resistor? A resistor will give you resistance. Okay. Really easy. Galvanometer. Galvanometer is the G one. Sir, what is a galvanometer? Okay, this is not your thing. Right? And then a rheostat. Oh, sir, what is a rheostat? A rheostat is a changing resistance. Oh, this is very interesting, guys. This is very interesting. Rheostat is a changing resistance. You know, okay, do you use water heater? Do you use water heater? You know, there's a knob that you change the temperature of the water heater. You are changing the rheostat. You are changing the resistance because high resistance means water will get hot. Low resistance means water will get cold. Common sense. Okay, and then battery is this. Same lah. Battery and dry cell is the same lah. Okay, no matter. Okay, so next, should I do this? Okay, guys, you know what? Since we're running short of time, can you please go home and do question 8? I want you to practice. Try. Go home and do question 8. Oh, there's only one question here. My God. Okay, guys. If I have the time next week, I will give you some more exercise because it's not enough here. I didn't update my exercise. I'm sorry, but I will give you more exercise to practice on your parallel and series circuit next week. Okay, so guys, please go home and do question 8. That's all I need you to do to understand the parallel and series circuit first. Right. So far, do you have any question? Am I making myself clear here? Am I? Are you clearer about series and parallel already? Okay, Lamin and Jenny, I hope it helps, guys. I hope it helps. This is the best simplified version I can give you. All right, next week we will do more exercise. I think hopefully you understand it more. Okay, so that's it for today, guys. Hope you have a wonderful Tuesday. I will see you again the same time next week. Okay, have a good one, guys. See you. Good night and bye-bye.